So, question 14 and the gold medal award winner for absolute rubbish, this question. So, it's a real shocker. We've got a council decides to hire a consultant to estimate the proportion of residents who use its library, and to do that, they're going to estimate a 95% confidence interval. Now, let me remind you what we normally do with a confidence interval, as we saw on earlier questions, is to calculate them. Anyway, for this question, we're just going to estimate a 95% confidence interval. And then it gets worse. I think what happened here is there was a Russian methods exam with this question, and I think it was just put into Google Translate, and this is what popped out, and someone just chucked it into our methods exam. Anyway, now we've got to calculate it to within an error of 0.01. What the heck does that mean? All right, are they talking about a margin of error of no more than 0.01 or whatever? Anyway, to within an error. That's new to me. So at the bottom line, we've got to work out what's the minimum sample size that should be selected to get within an error of 0.01. So we don't have any idea, or as a consultant, what the true proportion is. So in this one, we've got to assume that the proportion is 0.5, the worst case scenario. And then we just grab our formula from the old methods formula sheet. Here it is, the old margin of error formula. And we're going to use that one rearranged for n here to actually calculate what sample size we need. There is in the calculator in the E-activity sample size for a confidence interval. I'd start on the one beneath it into the Z-score. We want a confidence interval. This was a 95%er, and so solve for Z. And that's the exact Z-score, 1.96 pretty much. When we tap into the strip above, then that Z-score's already sitting there as accurate as we could want it. We put in 0.5 for the proportion, the margin of error 0.1, and then we just solve away for the sample size, and 9603.6 will round it up to the nearest whole number, 9,604, which is a pretty large sample for a suburban council. That basically is probably more than the number of ratepayers they've got, so they might need to rethink what they're about here. Anyhow, let's carry on. So what happens next? Resource limitations dictate that the maximum sample size that can be managed is 500. What is the maximum margin of error in, back to estimating, a 99% confidence interval? So we've got a maximum sample size of 500, but I guess that means we could go from anywhere from 1 to 500. And we want the maximum margin of error in our confidence interval. Well, we all know the margin of error depends on two things. Well, three, but if it's a 99%, Z's not going to be changing, so that's 2.576. But we've got P to play around with, and we know that if we want to make the margin of error as large as possible, maximum here, then we want P1 minus P to be as large as possible. So to maximize that, we know that P's got to be 0.5, and so this will come out as 0.25. And then the other factor is n. Now n is downstairs, so to maximize the margin of error, we want n to be as small as possible, which means it can be somewhere between the maximum sample size is 500, so the minimum would be 1. Otherwise, we don't have a sample. So, but of course, as soon as we go down to a sample size of 1, then we know this theory of creating a margin of error and a confidence interval this way falls very short, because we typically require a sample size of at least about 30. And we don't know what the proportion is to get a value for NP, N1 minus P. So basically, we can't answer this question using the given information. However, I'm guessing that what most students did when they came into this exam and got to this question is this. They read the question as that n has to be 500, despite the question saying it's a maximum sample size that can be managed. I am guessing that most kids would have said the sample size is 500, and what is the maximum margin of error? And so then it's back to what we were just doing really here. We're using the margin of error formula here. The Z score is 2.576, N is 500, we're not going to change that, and then we just have to assume that the P hat has got to be 0.5 to maximize E, just like we did in the previous part of the question. So we're kind of being examined a couple of times on this concept here. Anyway, when we substitute these in, the margin of error comes out to be 0.0576. However, it's not really a very good question at all here. And then the last part is fine. There's we can't complain about this. It's a bit of chat. The consultant decides to select the sample by standing on the roadside outside the library at lunchtime and asking a random sample whether they use the library. Good luck having 9,600 passers-by if that was the way they wanted to go. But anyway, identify a couple of sources of bias. So obviously standing outside the library, bias is the sample towards people who most likely going to, maybe why they're passing by the library is because they're going to the library. So that's a source of bias and the reason. And another one is it's asking passers-by. Because we're trying to sample people from the suburb, but passers-by don't necessarily have to be residents of the suburb. They might just be on their way some other suburb from another suburb. So 4 marks at the end on some fairly easy stuff, but the first half of this question gave it the award of the most shocking question on the exam.